Now we'll start with boric acids 3.2.2. There are four most important boric acids. Out of these, orthoboric acid is the most important and the stable one. The remaining acids are stable in solid state and change into orthoboric acid in solution. Number 1, orthoboric acid H3BO3. Number 2, metaboric acid HbO2. Number 3, tetraboric acid H2B4O7. Number 4, pyroboric acid H6B4O9. HbO2 plus H2O gives us H3BO3 boric acid. From metaboric acid, H2B4O7 plus 5H2O gives us 4H3BO3, which is also boric acid from the tetraboric acid, and H6B4O9 plus 3H2O gives us boric acid 4H3BO3 from pyroboric acid. Orthoboric acid or boric acid is a white crystalline chemical substance, triclinic, sparingly soluble in cold water 2.6% at 40 degrees Celsius and dissolves readily in hot water 37% at 107 degrees Celsius. This temperature variation in solubility forms the basis for its separation and purification. Preparation of boric acid on commercial scale. Number 1, from coal-minite. On commercial scale, boric acid is prepared from a natural calcium borate called coal-manite Ca2B6O11.5H2O by suspending it in the boiling water while sulfur dioxide is passed through it. Boric acid crystallizes out from the solution while the other product CaSO3 remains in the solution. Ca2B6O11.5H2O plus 2SO2 plus 4H2O gives us 2CaSO3 plus 6H3BO3. From borax, a hot concentrated solution of borax is treated with a calculated quantity of concentrated H2SO4. On cooling, crystals of boric acid formed separate out. Na2B4O7 borax plus H2SO4 plus 5H2O gives us Na2SO4 plus 4H3BO3 boric acid. The properties of boric acid are: number 1, boric acid is white, lustrous, crystalline solid having a soft, soapy touch, very slightly soluble in cold water but fairly soluble in hot. Number 2, it is volatile in steam. Number 3, it reacts with ethyl alcohol forming ethyl borate H3BO3 plus 3 C2H5OH gives us C2H53BO3 plus 3H2O. Number 4, when heated strongly it swells to frothy mass, losing water molecules. It is first converted into metaboric acid, then to tetraboric acid, and finally to boric anhydride. H3BO3 converted to HbO2 plus H2O, 4HbO converted to H2B4O7 plus H2O, H2B4O7 converted to 2B2O3 plus H2. Number 5. It is a very weak acid and ionizes to a very limited extent, mainly as a monobasic acid. H3BO3 plus H2O gives us BOH4 minus plus H plus. Number 6. Its solution has no effect on methyl orange, although it turns blue litmus red. It is partially neutralized by the caustic soda to give borax. 4H3BO3 plus 2NaOH gives us Na2B4O7 plus 7H2O. 8. When boric acid is neutralized by soda ash Na2CO3, borax is obtained. 4H3BO3 plus Na2CO3 gives us Na2B4O7 plus 6H2O plus CO2. Number 9. Boric acid, being a weak acid, cannot be titrated with alkalis in the usual manner. In the presence of glycerol, however, it can be titrated against a standard alkali using phenolphthalein as an indicator. Uses of boric acid. Number 1. Boric acid is used in medicines as an antiseptic. For example, dusting powder, boric ointment, and boric solution is used in eye wash. Number 2. It is used in pottery as a glaze because borate glazes are more fusible than silicate glazes and possess a higher coefficient of expansion. And it is used in the candle industry for the stiffening of wicks.